Okay guys, so in this video we are going to talk about deploying microservices. So let's get into it. So we're going to cover what a deployment is, and we're going to talk a little bit about why Docker may help us make this a little bit easier. And we're also going to mention or look at Kubernetes and how that can make it even easier to deal with more sophisticated forms of deployment. Now, this is probably going to be a two-parter where I'm going to split it, where I'm going to talk first and foremost about the recreate deployment and the blue-green deployment in this first video. And I'm just going to show you a very basic example of how to do this in a very manual fashion, so you can kind of get a feel for the steps that I take. And I'm doing this with Docker, but you could do it with any other way of deployment. Like, there's many ways you could do it. You don't have to use Docker at all. I'm just going to use it because it makes it easier for me. And in the second part, we're going to look at rolling deployments and how Kubernetes can actually help us when our use case is a little bit more advanced than these basic cases that I'm going to talk about with you right now. So the first thing we're going to look at is the recreate pattern. So recreate or recreate deployment is as simple as I have a system A and I want to switch that system out for system B. So basically what I'm going to do is that I'm going to just pull down my existing system. I'm just going to stop system A and then start system B, and then when that is available, I'm just going to allow all the users back in. That's pretty much it. So I'm just going to have what we call downtime. So that is what a deployment in essence is. Like, all the deployment really is the process of having some code that you wrote on your laptop. Let's say you make some updates to your website. Now you want to move that code from your computer to the production environment where your users are actually able to access that system. And that is all a deployment is, that process of getting that code into production. So recreate is probably the simplest way that you can do this. It is, you may recognize the old "we are down for maintenance" pages. Some companies still have this, so it's still something that goes on today. So these three patterns here are definitely all, even though this is a really old one, it's still used today. And blue-green is probably the most common one that companies use these days. And a rolling deployment is very similar to, it's still also very common. It's a bit more of a thing that you do either manually, but most people use Kubernetes to do this sort of thing. So let's have a look here at my package JSON. You can see here that I have two microservices or two services. And then I have this little server here for my users. All it says is users version 1. And then I have a users, well, a books API for just getting this piece of text here. And that's pretty much it. So if I now go and I look at my setup here, I say Docker PS, you'll see here that I have two versions of this, like users 2 and books 2. It's like two instances of this of these two microservices basically running, and then I have an Nginx instance. So if we look at my network, you'll see that all of these services are running now together. And the reason you can do this without Docker. So what I could do is that I could install Nginx on my computer or my remote virtual machine that I'm using out there somewhere in cyberspace. And I could just say that, okay, just run like expose on my virtual machine port 80. And then, of course, you have to have some domain as well that maps to that IP address. And that's going to be Nginx. So any user goes to my public domain is going to hit Nginx. And then I have the other services running together in separate processes on the same system under different IP addresses on different ports. And then I simply direct traffic based on what path the user is trying to hit on my system. So if we look at my configuration file here, you'll see that that's pretty much what's going on. So I'm using Nginx for this, and basically I've just declared this server block here because I only need one server. And then I create a root directory where I can find all my static files, and then I have a location where basically if anybody goes to the root of my application, we're just going to return 200 welcome. Let's pretend now that this is my amazing web application. It could have been another microservice that just happens to didn't pass all of my UI code, right? But we're just pretending right now. And then we have this, which is a regex, where I basically state that, okay, if there is an incoming request that starts with API-version 1 books something, then proxy that request to this IP address on this port, and then just append like to this URL, and then append like the remaining, like the tail of this path here. And then we set the default response type to application JSON. We don't really have to do that because like my microservices, they will take care of the response type. I'm just setting that there so that I can showcase how to do this recreate deployment. And then users do the same thing, and then I have this little thing here, which is just the error page directive that states that if I return a 5 or 3, then basically direct the user to this location. And this is my location down from maintenance.html. Since I haven't specified anything, I don't have to specify anything here, because what it's going to do is that it's going to by default look in my root folder here for this file, and this is the file that it's just a file that says, hey, we're down for maintenance, right? So let's have a look at this. So I have this welcome thing here, and I have an API as well, which is using my microservices. And then I say books, and yeah, it's all the good stuff is working right. So now I'm going to do a recreate. So what I'm going to do is that I'm going to go to my little window up here, which is just me. I can do it again, just for completeness sake. Exit. So I'm going to do docker exec it interactive shell nginx bash. So now I'm basically, you can think of this as the same thing. You would have done the same thing if you were using like a remote environment or something like that. But since I'm using Docker, I'm just SSHing, quote unquote. I'm doing quotation marks here, but you can't tell. I'm doing the same thing. So now I'm going to do, nginx-s for signal, and then I'm going to say reload. But before I do that, I need to change my configuration file. So currently the system is running, so we were just pretending now we have traffic, everybody's using our system, they're super happy. So now I'm going to pull down the system. I'm just going to do this, I'm going to do that, and then I'm going to do this. So what I've done now is that I've said that, okay, if anybody hits the root, just return 503. And that's going to hit this directive here, which is going to serve up this file. If anybody tries to go to the API, I'm just going to return a 503 with a static JSON string, and this is where the default type comes in. So I'm just going to return message 503. That's it. So I haven't done anything now, so I haven't deployed this. Like you can see, I can refresh as much as I want, and it's still working. So we can just pretend that the users are happy, everything's good, bam. And then I do that, and shit, now my system is down. Oh, such a horrible user experience. Oh, it's terrible. But it works. And quite a lot of companies still do this. Like, it's not uncommon to still see this today. Now, there's actually a good reason to do this. I would say that there's two good reasons to make a deployment, like to do a deployment in this fashion. The first reason is if you have a system, like let's say you have an internal system for your company, you have your own little personal blog, or you have your own private thing or something like that. You're not Facebook, you're not even a mid-sized like large corporation, or like you don't necessarily care if there are a few users who have to come back later. Then this is the easiest thing in the world, because what I can do now, which is absolutely beautiful, is that I can go in here. Like I'm not going to do it because it's just going to be a wasted time. But I can say something like docker stop. Now let's see. No, actually let's do that. Docker stop books 2. So I just stopped books 2. That API is no longer there. And if I go to books, that doesn't matter, because my load balancer, which is the thing that this routing system here, it's stopping at this point. It's not sending my request to my books API. It's actually stopping right here. So Nginx is just, you can think of it as a screen. It's just acting as a barrier between my system and the user, and it's just saying, okay, no, we are in maintenance mode now. Just return 503 with message 503. It doesn't matter if the system is if it's up or running, right? So let's go and pull that back up. Actually, I wonder if I can. Let's do that. Books 2. Yeah, I forgot. Of course. Docker run users. Let's actually change that to books. and say books like so, docker ps, and I think that's it, right? Let's see if I need to re-add you to my network. I think so. Network inspect demo. Yes, I need to do that. But let's pretend that I just actually that I updated the service. I'm going to do that in just a moment, just to show you how to do it. But I'll save it for the blue-green case. Network. Let's see, H4. I can never remember that. Connect. Books 2, like so. Sorry, I forgot. It should be demo 2, books 2. Docker network inspect demo. And let's see here. So users 2, and then we have books, which is now running on port 2. So I need to remap that because, well, this is one of those cases where it would be nice to just have that as a DNS type of thing, right? But that's just not the world we're living in, right? So users 2 should be on port 6, which is okay, and this should be port 2. So now we're pretending and saying that, oh yeah, we've done all of our nice updates or stuff like that, and then we're just going to pull all of this system up again. And let's reload it, and now everything's back to normal. Everything is back to normal. Everything is good. So as I was saying, like, this is not necessarily the best user experience, but as I was saying, it's very simple. It's very easy for me as the developer to do this. It is very comfortable because I know that my system is safe from all the incoming traffic. Just from a convenience perspective, it's a useful thing, but there's also one other case where it's really useful, and that is if you're going to do a data migration. Now, a data migration is just a situation where you have saved a certain type of model. Let's say that you were saving a user with just their name, and now you need to add, I don't know, their email or their age or something like that. You need to add more information to the system. Your code gets updated, and now your new models contain more information than they used to. Now the problem, or maybe it's just something of that nature. Now the problem with that is that you will have two different types of records. So you will have the old users who are already using your system, and they haven't filled in this information in your application. And then you will have the new users who have this information. So what do? Like, there's usually 2 ways that you can deal with this, or 3 technically if you have that concept. You can, if your language supports having optionals, so to say that a value is optional, then you can always just add an optional value to your model, because then you know that it may be there, it may not be there. But that's not a very sustainable thing to do long term, because if every single thing that you add is going to be an optional, it's going to be held to maintain in the code. So what you usually do is either you create some special type of code at the database layer where you're actually getting your data from the database, and then you just check, is this the old model or is this the new model? If it's the old model, then you basically polyfill in the information, or you shape the data into the new format, and when you then save the data, you save it in the new format. So you read the data in the old format, and then you save it in the new format. And this is an iterative approach where, well, you're pretty much going to, over time, migrate everybody over as long as they're using the system. Now, the problem with that is that, of course, you need to have some ugly rewrite code, or like basically a special code that does this, but you also have to wait, most likely for several months, depending on how big the system is or how many users we're talking about here. It's going, because it will only work when they've actually used the system, so that these rewrites actually happen, or that migration happens. And sometimes, I mean, some users, they've just used your system once and they never update, so you're still going to be in this inconsistent state. So you will always have that little piece of ugly code that is going to have to be there, because you still have to wait, or do something or remove users who have these old models if you don't do it in any other fashion, right? And that's the other thing you can do. And that is the other way to do that is to say, okay, I'm going to do something like a migration job. And a migration job is just that you run a batch job. You basically say, okay, I'm going to rewrite all of these old models into the new format. Just one fire, we're going to run it. And depending on how big the data is, it can take several hours, or it can take just a few minutes. Now, if you're going to do something like that, what's really nice about that is that it's surefire. Like, you just run it once and everything is consistent and everything is clean. The iterative approach, not so much, but it's safer. Iterative will work for pretty much all the situations. But if you're going to do that big rewrite, like the big migration job, this is a really nice way of doing it. Like, this is perfect because you can't have traffic on your system while you're running the batch job. Because if you have that happening, it's very likely, or it can happen, that your users are using your system while you're rewriting all the models. It's bound to break. Like, you might just write in things that are inconsistent, or like something might actually just go down because you're doing that. So doing this is a very nice use case for a big migration job. Like, you're basically just shutting down the service for a little while for approximately the time it takes the batch job to get finished, right? So don't dismiss this approach just because it's old, because it is actually still very useful, especially for that sort of use case. So let's look at the blue-green deployment system pattern. All right, so let's say, for the sake of argument, I'm going to make some updates, right? And with blue-green, the idea is that, okay, I have a system A and I have a system B that I want to change over to. But I don't want to have any downtime. Okay, so what I'm going to do is that I'm going to start system B next to system A, and then I'm going to just roll over all the traffic to system B. And when everybody's over on system B, I will tear down system A. Makes sense, right? So what we're going to do is that we're going to change this to version 2, and we're going to change that to version 2. Let's ignore Semver and like all of this other stuff and just keep, we're not perfect. We're just going to be simple about these things. So then we're going to go down here and we're going to say build. No, actually I need to commit first. Commit stuff, because I'm all about the good commit messages. Git log. And then I grab the commit message, and this is just me doing this is a convention that I like to follow. You're more than, feel free to steal this if you want it. So the reason why I do it this way is because when I build a new image, I want the commit ID as a version number. That way I know that when I'm building this image, I can very quickly find what code is actually in that, is actually part of that image. Docker images. As you can see here, I have a few images now. So I have this first version, second version, and this is our now third version. Okay, Docker PS. Let's see here. So I have a books 2 and a users 2. So let's start Docker run. Let's take no, not Docker. Docker is even better than Docker, but it hasn't been developed yet. So we're going to have to stick with Docker. Run. Something like that, and let's call that books 3, and then let's just put that commit there. So let's start that, and then let's say users, and let's call that users 3. Hopefully all that worked. Docker PS, and now we can see here that I'm running. So I'm running one service which has this new code with users 3, and I have a version of books 3, and then I have the old versions, version 2s, or like the second versions of these applications. So if we look at my load balancer now, I still haven't added these to my network yet, so they're safe. Like, they are running in their own separate network, and these three services, they run together. But I can even when I do that, let's say network connect, like so. I can say books 3, and then I can say users 3. So now they're all in the same network. like so. Now you'll see here that users 2 is running on this IP address, and Nginx is on this IP address, and then we have books 2 that is on this, and books 3 is on this, and then we have users 3 which is on this, which is all great, right? So now they're all running in the same environment, but I'm still safe. Like, nothing has changed because, well, Nginx is still doing its thing. It's still just pointing to those IP addresses. You'll see that it's still on version 1. So now that I want to do this red-blue thing, I'm going to do this. I'm going to say that, okay, I'm just going to repoint these proxy paths to the new thing. I don't even have to do any downtime or anything like that because the system is already up. Now the danger, the thing that's going to make me nervous here is that and the reason why I keep the old version before I tear it down is because if I deploy now and something goes wrong, what do I do? If I've destroyed the old containers, I need to be able to do something that we call a rollback. And the easiest way to do a rollback is just to keep the old version of the code ready just in case, and then roll over, see if everything works. If it doesn't, roll back. So let's have a look at books 3. It's on port number 4, so we're going to change that to 4. And then we need to see users 3, and that is on 5. Okay, like so. Still nothing hasn't changed. Everything is good. Everything is good. I can sit there and refresh as much as I like. And then let's do the reload. Ta-da! So that's pretty much how it works. Like, we didn't have any downtime. We just flipped it. The system is still running. Like, I can still, if I wanted to, oh shit, something went bad, really bad now, I'll just move that back. I'll just do another reload. And we're back to the previous version, so I can reload. I can roll back very quickly, and this is one of those reasons why I really liked having the commit ID on my containers, because then I can roll back to the most like a safe version, like the last working commit that I had. So, no, but let's, for the sake of argument, say that everything worked, and I'll just reload my configuration file, and everybody's happy again because they're using our new awesome code. And then I can go down here and I can say docker stop books 2. And then I can say docker stop users 2. And if we look at my inspect now, you'll see here that there is nothing on this network. So these like now we're using version 3, or like the third version of these services, and we had no downtime. So this is pretty much a blue-green deployment. So what I want you to take away from this is that the benefits of the recreate deployment is that it's very simple. And if you're doing something that requires a data migration, like you want to just rewrite all your models in one go and never care about them again, this is a very efficient way to do that. You're simply configuring your load balancer like Nginx or some other thing, or like a reverse proxy. It doesn't really matter what you have, your proxy server or gateway, to stop all traffic and just say, hey, you know what, we're doing maintenance. So it's like this screen that shields your system. And then when your new system is being deployed on behind the screen, you just enable all the traffic to go through again. And for that's the good part about it. The bad part is, of course, your system needs to be down and you have downtime. For a blue-green deployment, the benefits is that you pretty much have this ability to not have any downtime loss at all. The problem there is that you can't run a batch job migration as easily, because if the system is still active, then odds are that you're going to rewrite the models and maybe something breaks while users are actually using that system at the same time. And it also requires a little bit more resources because you're spinning up 2 instances of the same system and then just rolling everybody over. But as I said, like, it's really this is how quite a lot of companies do. I would say the majority of them do it in this fashion. And in the next video, we are going to have a look at how to do rolling deployments and actually use Kubernetes to do a lot of this stuff, because what you've seen so far is a very basic use case. All the stuff that you've seen here, you can apply in your own personal project, at small consultancies and like your own startup or stuff like that. This works perfectly fine for anything that is like a smaller application. For larger systems, we're going to need something a little bit more heavy duty, and that's where Kubernetes comes in. But we're going to look at that in the next video.